In item 1 on the second exam, not the first, we're going to have a truss that we're trying to find specific member forces. And those two specific member forces are these two bottom ones. That happens to be associated with one single joint. And with that, then, that will actually make things a lot easier as we go about trying to find what we've been requested to find. That joint free body diagram there at A is going to have then the two member forces and the horizontal reaction. Now, I haven't shown arrows, I haven't shown directions of any sort yet because I haven't figured any of that out. But that's a beginning point. I do need to find, since I've got three unknowns, only two equations here, I need to find one of these through a bigger system. And since one of these is our horizontal reaction, then I can go back to the global free body diagram. I can take a look and see that, well, gee, I've got AX here, and we already know that GX is there. Then we've got a GY there, and we'll have our tension in our cable up there, which will be equal to the weight, since that's what's causing the force in the cable to begin with. Right, so that allows us then to actually write from global equation of equilibrium, or rather from global free body diagram, and then we can some moments about G, take counterclockwise as positive, we have 2 times AX minus 6 times W, then plus 3 times T is equal to 0, but T is equal W, and so therefore AX is equal to 3W over 2, or 3mg over 2. Confirms the direction for AX, from which then it's easy to figure out what direction AB must be going, and which direction then AG must be going. Note that AB is at a dimension or orientation, that is, of 6 horizontal, 5 vertical. Right? So that allows us now to come back and from the point A free body diagram, then we can write that center forces in the X tells us that we have A sub X minus the X component of B must be equal to 0, so therefore ABX has to equal A sub X equal to 3W over 2. We haven't found numbers for that yet. And then by sum of forces in the Y, we'll have AG minus the Y component of AB has to be equal to 0, so therefore AG is equal to ABY, but ABY has to be in the relationship of 5/6 of ABX to be in the right proportion, has to be smaller. And so what that would mean that we have 5/6 of 3W over 2, or 5/4 of W for that one. Now we're almost done, but not quite. We now need to find our actual values that we've got here. Then all for AB and for AG. Okay, AB then equals square root of 5 squared plus 6 squared over, see that would be the hypotenuse, over 6 times our AB x. So that's, let's see here, we got 25 plus 36, take the square root, divide by 6, that's 1.3017, right? So 1.3017 times ABX, which is equal to 3/2 of W, which is 60 kilograms, times 9.81 meters per second squared, and we get 1149 newtons, and that's going to be in compression. And then for AG, we get 5/4 of W, so 5/4 of the mass times the acceleration of gravity. And so 1.25 times 60 times 9.81 equals 736 newtons in tension. And there's your two forces.